Unit 1, Homework 6, we're going to be looking at factoring using the AC method. So the first question is, what are we trying to factor? Well, a lot of the things that we're going to be trying to factor are called trinomials. So the standard form for a trinomial, and especially with the square term with a quadratic, is going to be ax squared plus bx plus c. So what we have here then is, if there was a 2x squared minus 3x plus 4, we would have that a is 2, b is negative 3, and c is 4. So what's ever in front of the squared term, which is our quadratic term, would be our a coefficient. Whatever's in front of our x term or our linear term would be our b coefficient, and whatever our constant is off by itself would be the c coefficient. Now, it doesn't have anything to do with the order that they're given. It has to do with what appears in front of which term and what is a constant. So let's go ahead and look at a quick example. If we can identify the letters a, b, and c. Let's say a negative 3x plus 4 minus 7x squared. So the question is here, can you identify a, b, and c? Well, you might think a is negative 3 because it's first, but remember, we have to rewrite these in descending powers of the exponent. So squared would go first. Remember, this is an implied 1, so that would go second. And then our constant would go last. So here, negative 7 is a, negative 3 would be b, and my constant term is 4 would be c. So again, if you don't have a, b, c in order, you need to make sure they get into order before we start factoring, and that will make this a lot easier. Now, there's several different ways that you can factor a trinomial, and you probably were introduced to more than one way as well when you've learned this information before. But I'm going to show you 2 different ways and then allow you to pick. Now, the AC method is the method of choice that the math department has decided on that we'll be covering, but there's also the reverse FOIL method. And I just want to mention it because it's familiar to a lot of people, and if you're used to using that method, I would encourage you to continue to use it. So let's go ahead and look at an example. We're going to use the reverse FOIL and the AC on it to show you 2 different ways. And let's go ahead and just look at factoring the trinomial. So factor the trinomial. And the trinomial that we're going to have is s squared plus 9s plus 14. Okay, so it's already in order. Highest power is squared, goes down to constant. Now, the first method I want to look at is called the reverse FOIL. And this is kind of just a trial and error approach, which actually most of the approaches are. You can remember when we learned to FOIL, first outside insides last, when we learned to multiply binomials, we use that acronym first outside insides last. Well, if you think about s squared, in order to get an s squared, you need an s in these front positions. Now, to get this last position, you need a 14. So you could put a 1 and a 14 here. 1 times 14 is 14. But notice when you check s times 14 is 14s, and 1 times s is s, you don't get a 9, you get a 15. So that can't work. So again, it's trial and error. But once you work a lot of these, you start to see a pattern, and it will be less trial and error and more correct solutions. So besides 1 and 14, so again, we were looking at 14. 1 and 14 didn't work. 2 times 7. Let's try 2 times 7. 2 times 7. I need a plus sign here, and this is a plus, so I put pluses in between. And if I multiply it out real quick, I get s times s is s squared, so I'm going to check this. Plus 7s plus 2s plus 14. And again, that's my firsts, outsides, insides, and lasts. When I combine like terms, 7s plus 2s is 9s plus 14. So this checks. I got exactly what I started with. And again, this is called the reverse FOIL. It's trial and error. I'm looking for 2 numbers multiplied together that give me 14, added together that give me 9, and you can see it's right here. 2 plus 7 is 9. 2 times 7 is 14, so that's my combination that works. Okay, now let's go ahead and go to the AC method. AC method. Now with the AC method, you might imagine you need to identify A, B, and C. So for this example, A is an implied 1 because there's an implied 1 in front of the s squared. B is 9 and C is 14. So this is how I do the AC method, and everybody sets this up a little bit differently. Some people use factoring by grouping, and I'll show you that as well. And then I'll show you my little grid approach that I take to these two. So I make a big X, and up here goes A times C, and down here goes B. So A times C would be 1 times 14 is 14. B is 9. So I'm looking for two numbers multiplied together that give me 14, added together that give me 9. So I could put a 1 and a 14, or a 2 and a 7, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. None of those go into 14. Now as I look through my options here, 1 times 14 is 14, but do 1 and 14 combine to 9? And the answer is no, so I'd cross those out. 2 times 7 is 14. 2 plus 7 is 9. So there it is. There's my numbers I'm looking for. So what I do then is I take my original trinomial and I rewrite it. So I take s squared. Now instead of plus 9s, I'm going to say plus 2s plus 7s plus 14. So what I've done is I've taken this 9s and I've broken it up to give me 2 plus 7 is 9. So that's all we've done. And now if you look at this problem, really it's factoring by grouping. So factoring by grouping. There's my two groups. Now sometimes you'll have to rearrange the groups because you won't have a GCF in the group, but this one we have. So for this one, s squared and s, I have an s. If I factor out an s, I'm left with s plus 2. Now in my second group, the GCF between 7 and 14 is 7. If I factor out a 7, I'm left with s plus 2. GCF between the first two groups is s plus 2. S plus 7 are my remaining factors then when I do factoring by grouping. And there is my factored form. Now notice it's the exact same thing that we got up here when we were working with the reverse FOIL method. Now remember, you can always check your answer. S squared, 7s plus 2s is 9s. 2 times 7 is 14. Remember, I am also going to mention that little grid, or that little box I like to work with. So we put in the s squared, and I'm coming right over here. I'm putting the s squared and then the 2s and the 7s I'll put in my diagonal, and then 14. And these happen to all be positive. So I just took this original problem that I had up here, and then the 9s, if you'll notice right here, the diagonal, the 2 plus 7 is 9. So GCF in the first column is s. GCF in the second column is a 2. GCF in the first row is an s. Boy, those kind of look like 5s. And in my second one is a 7. Now everything is positive, so I'm left with s plus 2 times s plus 7. So a lot of times you'll see this called the X box method, because here I have an X and here I have my box. But it's the same as the AC method. Okay, it's just a visual representation of that. So whether you want to use reverse FOIL or the AC method using grouping, so this is factor by grouping, or you want to use that factoring by this box method, it doesn't matter. But I would guess that a combination of things would be really helpful. So for instance, if you see anything that works really quick by reverse FOIL, you would take that method. But if you don't see anything that will work with reverse FOIL, you'd choose another method. Okay, let's try another problem. So for this one, again, our directions are to factor. Let's use v squared minus 3v minus 10. And again, factor are the directions. So let's try a few approaches. Let's try reverse FOIL. So for the reverse FOIL, if you don't like this method, I'll cover another method in a second. I need two variables multiplied together that give me v squared, and of course that would be v and v. Now I'm working with this 10. Okay, so I've got this 10. And I have 1 times 10 and 2 times 5. Those are really the only ones I can come up with. So I need a negative 10. And when I add them together, I need a negative 3. So I think a plus 2 and a minus 5 would work, because 2 minus 5 is negative 3. So then I plug these in, plus 2 and a minus 5. And then I can check it real quick using the FOIL method. Firsts would give me v squared. Outside minus 5v. Insides would be 2v. And my lasts would be 2 times negative 5 is a negative 10. Combining my like terms, I have v squared minus 3v minus 10. So it checks. And on a test or a quiz, you can check every single one of these problems. So you should never miss one on a test that is just the FOIL, or sorry, the factor, because I can just get my answer and FOIL it out and check my work. So that's the reverse FOIL. Let's go ahead and look at the AC method as well. Now with the AC method, let's rewrite our problem here so it's down here. I need to identify A, B, and C. So A is this implied 1 in front, B is negative 3, and C is negative 10. Okay, so here's my big X, helps me keep track of things. So I have A times C. So that's 1 times negative 10 is negative 10. And down here goes B. So negative 3. So I'm looking for two numbers multiplied together that give me negative 10, added together that give me negative 3. Well, I could start with 1 and 10, or 2 and 5. Those are the only way that 10 breaks down. Well, as I look at this, there's no way that 1 and 10, no matter which is positive or which is negative, there's no way that's going to get me anywhere close to a 3. I could do a negative 9, an 11, a 9. It's just not going to get me to that negative 3. So let's see if we can manipulate these signs. If I made this a negative 2 and this a positive 5, 5 minus 2 would be a positive 3, so that's not going to work. Let's look at making this one a positive 2 and this one a negative 5. So again, that one didn't work. 2 minus 5 is negative 3, so there's the ones I need. And then we rewrite this negative 3v. So we take this negative 3v and we rewrite it as 2v minus 5v. Now, could you rewrite it as negative 5v plus 2v? And the answer is yes. You might have to rearrange your terms though. So we have v squared minus 2v minus 5v minus 10. Factoring by grouping. There's a v that's common in my first group. If I factor out a v, I'm left with v minus 2. Now in my second group, there's a negative 5 that's common. If I factor out a negative 5, I'm going to be left with v, let's check that. Okay, I see what happened here. I copied this down wrong. This is a positive 2v, so there should be a plus sign here and here. Okay, if I factor out a negative 5, it'd be left with v plus 2. Negative 5 times v is a negative 5v. Negative 5 times 2 is a negative 10. Now my GCF in each group is v plus 2. And if I factor out a v plus 2, my remaining factor is a v minus 5. So this is my factored form. Now again, you can check this very, very easily. Just go ahead and FOIL it out. V times v is v squared minus 5v. Those are my outside. My inside is plus 2v. And then my lasts would be 2 times negative 5 is negative 10. And then group these together. And it checks. And also this is the same as the form that I had up here, v plus 2v minus 5. Of course, I want to look at my little box method. I would still take where I am from right here. I have v squared plus 2v minus 5v minus 10. Okay, in my first column, the GCF is v. In my second column, the GCF is a 2. So I'm going to put a plus 2. In the first row, my GCF is a V. In the second row, my GCF is not just a 5, it's a -5. So you can see here I'm left with V plus 2 times V minus 5. So there's two different ways of doing that. We get the same answer either way, but I do like the box method. It seems like I make fewer mistakes with that one. Let's go ahead and look at another example. Let's look at a squared minus 6a minus 27. Reverse FOIL. So for the reverse FOIL method, I need two variables multiplied together that will give me a squared. So clearly it's going to be a and a. And then over here under 27, let's write out all the combinations of numbers that I can multiply to get 27. It could be 1 and 27. 2 won't work. 3 times 9. 4, 5, 6, 8, that's it. Now somehow I need two of these that will combine to give me this -6. Okay, so multiply, I have 27, combined, added together, I get -6. There's no way that 1 and 27, no matter what's positive and what's negative, is going to give me a -6. So I'm done there. This could work. 3 minus 9 would work great. Okay, so that would be plus 3 and minus 9. Now we could check our work. A times a is a squared minus 9a plus 3a for my outsides and my inside terms, and then my last terms would be 3 times -9 is -27. Combining your linear terms or your inside terms, that's a minus 27. You can see that this checks. So again, we're always comparing it back to our original. So let's go ahead and do the same problem using the AC method. So for those of you who are used to the reverse FOIL, you can watch along with the AC method if you would like. Now the AC method is nice because sometimes the reverse FOIL, it's kind of hard to come up with the correct combination. The problems we've done so far have been pretty easy. So in this case, A is 1, B is -6, C is -27. To make a little bit more room for that, C is -27. B is -6, C is -27. Again, the coefficient in front of the a squared is 1, in front of the a is -6, and the constant is -27. So AC method. So for the AC method, I have two numbers multiplied together, in this case a and c. So in this case, a times c would be 1 times -27, which would be a -27, and then b down here would be -6. So again, I'm looking for two numbers multiplied together that give me -27. So let's just try, don't worry about the negative part. Really, the only options we have are 1 times 27 and 9 times 3. Now, which combination of these would get me to a -6? There's no way that 1 and 27 will work. -6 will work if I have a +3 and a -9. So I will take the -6a and I will rewrite it as a +3a minus 9a. So this 3a minus 9a was that -6a. Now we do factoring by grouping. Greatest common factor in my first group is a. Greatest common factor in my second group is a -9. Now if I factor a -9 away from here, I'm left with a plus 3. -9 times +3 is a -27. So your sign changes when you factor out a negative. GCF in my first group is a plus 3. And if I factor out that a plus 3, I'm left with a minus 9 from my first and then my second term. So we have already checked this up above. This matches what I had for the reverse FOIL. I want to look at my little box method. So my box method comes from here. I have my a squared and my -27 that you plug in for your box. And then along the diagonals go the 3a and the -9a. So again, this diagonal right here will always add to this linear term. So first column is an a. Second column is a +3 that's common. First row is an a. And then down here I have a negative 9. And so you can see I've got it all set up, a plus 3, a minus 9. And the cool thing about the box method here is I don't have to double check it because it's all right here visually. I don't have to FOIL it out. A times a is a squared, a times 3 is 3a, negative 9 times a is a negative 9a, and a negative 9 times 3 is a negative 27. So not only does it show the factoring, it shows the FOIL as well. And it's a good way to double check. Okay, let's go ahead and look at another example. Now for this example, whoops, let's add a page here. For this example, let's try to factor w squared plus w plus 4. Oh dear. Okay, so let's try reverse FOIL. So when I get started with reverse FOIL, I kind of start setting up with my parentheses. I need two values multiplied together that give me w squared. I think that w and w would work. And then I need to put two numbers in here multiplied together that give me a 4, but added together give me a 1w. So I could use 1 times 4 or 2 times 2. Really, those are my only choices. There is nothing I can do to combine 1 and a 4 to get a 1, or 2 and a 2 to get a 1, unless I divided, but I have to add or subtract. So if I put a plus 1 plus 4, that's going to give me a 5w. That won't work. If I used a 2 and a 2, that's not going to work either. So there's nothing that will work here. So this is not factorable. And that's kind of a bummer. So this is not factorable. So that's what we need to state in our solution, is that it's not factorable. Now how would we have come up with this with the AC method? Now the AC method, again, in this case, A is 1, B is 1, and C is 4, and those are just pulled right off, 1, 1, and 4. AC, I have 1 times 4 is 4, B is 1, two numbers multiplied together that give me 4, added together that give me 1. You can see 4 times 1 is 4, 2 times 2 is 4, 4 plus 1 is 5, 2 plus 2 is 4. I can't switch the signs on these. There's no way that I'm going to get a 1 out of this. And then also up here in the reverse FOIL, because both of these signs are positive, I know both of these signs have to be positive too, so that tells me I can't subtract. This isn't going to work, neither is this. There's no combination that will work, so it's not factorable. You have to be tenacious with these. You have to check all the factors, and checking 4 isn't bad, because with 4, it's just 1 times 4 and 2 times 2. So again, this one is not factorable, and not everything will be factorable. Let's look at another example. Again, our directions are to factor. Now this one has 4 terms. U squared plus 5u plus 6u plus 30. So this one is ideal for grouping. I would not want to combine these and then try and factor this, because it's already set up for grouping. So a couple different ways you could work this. I like my box method. So first column, I got to get that straight. Second column, first row, second row. So this tells me that this factors into u plus 5 times u plus 6. And again, I don't even really need to check anything, because u times u is u squared, u times 5 is 5u, 6 times u is 6u, 6 times 5 is 30. So it's all visually there. The check is there as well. Now if you use grouping on this, in my first group the greatest common factor is a u, so I'd factor out a u plus 5. In my second group the greatest common factor is a 6, so I'd factor out a u plus 5. Then I see the GCF of both groups is u plus 5 times u plus 6. Okay, and then from here what we can do is we could FOIL this out and check it. So u times u would be u squared, plus 6u plus 5u, outsides and insides, plus 30. And of course, combining these middle terms, which in this one we really don't need to because we were not given the middle terms combined, so I guess from here it checks. So again, if it's already in 4 terms, you really shouldn't have to split it up. You should just be able to go through factoring by grouping. So let's go ahead and look at another example where this is the case. We have 4a squared minus 7a minus 28a plus 49. Now again, these are already in 4 terms, so there's no need to combine these middle terms because that's the whole idea of the AC method, is to split that linear term into 2 terms and then use grouping. So this is already set up for us to use grouping. I'm going to use the box method first. 4a squared minus 7a minus 28a plus 49. Okay, now this time I'm going to try and get my rows and columns right. Okay, column. My greatest common factor in this first column is a 4a. Greatest common factor in my second column is a negative 7a and a 49, so the GCF between there would be a plus 7. Now over here the GCF is going to be an a, and over here my GCF between the negative 28a and the plus 49 is going to be a negative 7. Okay, so let's check this out. A times 4a is 4a squared. A times 7, oh, that's not negative 7a, so that means I have a mistake. So we need to go back and say, okay, well, this has to be a negative 7 in order for this to work. So on this second column, I could have factored out a positive or a negative, but I went with the positive and I was wrong, and I can double check it when I take a times negative 7. I have to get a negative 7a, so I needed to factor out that negative 7. Same thing here, negative 7 times 4a is a negative 28a. Okay, and then from here, negative 7 times negative 7 is a positive 49. So I needed to make that quick correction, and I got that when I checked my work. I just ran through the table one more time and realized I made a mistake. So this is my factored form. Now if you want to do this same problem factoring by grouping, you're going to kind of run into that same difficulty. In our first group, we have an a as my GCF, and I'll be left with 4a minus 7. Now here in my second group, it looks like I could pull out a plus 7 or a minus 7, and again it's going to be a trial and error. If I pull out a plus 7, I'm left with a negative 4a plus 7. And if you notice, I don't have a GCF anymore. This one is 4a minus 7, this is negative 4a plus 7, so they don't match. So this does not work. So what I want to do then is to pull out that negative 7. Now when I pull out a negative 7, I'm left with 4a minus 7. And now I have that nice little GCF. I'm left with 4a minus 7 times the quantity a minus 7. And you should you should FOIL that out to check it. But again, that's why I like this box method. It gives me that nice visual of not only my solution, but also an automatic check. Okay, let's go ahead and look at another example. So for this example, again, our directions are to factor. Let's look at 4v squared plus 9v minus 28. Now this is where, if you were relying on the reverse FOIL method, this is where you kind of run into some trouble. This is a tough problem. This is hard because to reverse FOIL this, not only do you have to deal with the fact that we have a 4 here now, but you also have the 28 on the end. Before, the reverse FOIL was easy when I just had a v squared. So I don't want to rely on that reverse FOIL. I want to go after that AC method on this one. Reverse FOIL is definitely doable, but there'd be quite a bit of trial and error involved. A is 4, B is 9, C is negative 28. So up here is AC method. A times C, whoa, got some big numbers there. 112, so this would be 4 times negative 56. So we have 4 times, I'm sorry, I wrote the answer down. So that'd be 4 times negative 28. 4 times negative 28. So that'd be negative 112, and then a b value is 9. So I'm looking for two numbers multiplied together that give me a negative 112. And I'm just going to start with the positives. I don't want to worry about the negatives quite yet. So it'd be 112 times 1. It'd be 2 times 56. 3 doesn't go. 4 will go. Let's see. 4 will go 100. We go 25, 28 times. Okay, and again, these are trial and error. You can't just look at this and say, I don't know. You can't give up. You have to check your numbers. 5 won't go. 3 won't go. 6 won't go because 2 and 3 didn't go. 2 went, but not 3. Let's look at 7. I think 7 will go. 7 goes into 112. Let me see. 7 goes into 11 once with the remainder of 4. 7 times 6 is 42. And 8 will not go. 12 times 8 is 96. 9 will not go because when I add up the digits, they're not divisible by 9. 10 won't go. 11 won't go. 12 and 13 won't go. And neither will 14 or 15. So again, you have to just run through these. But I see the one I need right here. These are the ones I need because I can combine these to get a positive 9. If the 16 is positive and the 7 is negative, 16 minus 7 is 9. So again, you make this whole list of values and then you find the two that will work. Okay, so we take this and we rewrite it. 4v squared. Now instead of the plus 9v, we write minus 7v plus 16v minus 28. So again, these combine to give me that 9v. Okay, grouping. Not much is going on here. There's just a v that's common. I'll be left with 4v minus 7. Now over here, I think we could probably pull out 7 times 4 is 28. I think we could pull out a 4. I'd be left with 4v minus 7. Now if I'd only pulled out the 2, I would have had 8v minus 14, and then I would look at that expression and say, oh wait, there's still something that's in common. The 4v minus 7 is common, so I go ahead and pull that out. And when I factor out 4v minus 7, I'm left with v plus 4. So there it is. And again, you can check your work by foiling that out. I like using my little grid method here. So 4v squared minus 7v, 16v minus 28. Now the nice thing about the box method is it checks its own answer when you double check your work after you get done factoring. So first column, 4v squared 16v would be 4v. Negative 7v, negative 28 would be a minus 7. Across the first row, it looks like I could pull out a v. And across the second row, it looks like I could pull out a 4. So here's my factoring, 4v minus 7, v plus 4. Well, let's go ahead and double check before we move on. And here we have v times 4v is 4v squared. V times negative 7 is a negative 7v. 4 times 4v is 16v. 4 times negative 7 is negative 28. So this checks. And I don't have to FOIL it out because it checks within the box. Okay, so I think we've looked at the factoring by grouping quite a bit, quite a few different ways, but we're just going to continue to work a few more problems because these are kind of tough problems, and the key is you can't give up on checking for the combinations that will work. So let's go ahead and factor another one. Let's factor, let's do a c. Let's do 5c squared minus 34c minus 7. Now if you do a reverse FOIL on this, you know it's going to start with a 5 and have a 7 involved as well. So you can reverse FOIL this, but it is a little bit more complicated. I'm just going to go after the AC method here. A is 5, B is negative 34, and C is negative 7. AC, we're going to get some big numbers out of this. So if we have AC, we have 5 times negative 7. So we get a negative 35 here. And then down here we have negative 34. So I have 1 times 35. 2 won't work. 3, for 5 and 7. Those are really my only two options here. So when I look at 5 and 7, there's just no way I can combine these to get a negative 34. However, I think the 1 and 35 will work if the 1 is positive and the 35 is negative. So I take this and rewrite it. I have my 5c squared. Now instead of a negative 34c, I'm going to write a negative 35c plus c minus 7. Factoring by grouping, I could pull out a 5c and I'd be left with c minus 7. And then over here, if there's that tricky one, I'm going to factor out a c minus 7, but I want to put a 1 here so when I reverse FOIL it, it factors correctly. So I see my GCF is c minus 7. And then I'm left with 5c plus 1. Now this is that tricky one. The 5c is obvious here, the 1 is not. But this is how it correctly factors. Now one way to work around that 1 kind of being an issue is to use the box method. 5c squared minus 35c, c minus 7. So here, first column, c. Second column is a negative 7. First row is 5c. Second row is just a 1. And see, there's where that 1 pops in over here. So I'm left with c minus 7 and this 5c plus 1. And then before I say that's my final answer, I want to run through this one more time. 5c times c is 5c squared. 5c times negative 7 is a negative 35c. 1 times c is c. 1 times negative 7 is negative 7. So again, that box method is nice because it checks itself when you're done. Okay. So reverse FOIL seems to work with ones where the leading coefficients are a 1, but when the leading coefficients are anything other than a 1, we get some pretty big numbers. And again, you can't give up on these. You can't just say, I don't know, that number's too big. You have to try all the combinations. So don't give up on these. You always want to try the combinations. Let's go ahead and try another one. So directions are to factor as usual. 14x squared plus 41x minus 28. Now just as a quick note, a lot of the examples will say factor by grouping or factor using the AC method. The computer has no idea how you're factoring, so factor using the method that you like best. That's some good advice. Choose a method you're good with and then stick with it and refine your talent there. So first of all, when I look at this, 14 and 41, they don't have a GCF. 14 and 28 do, but because the 14 and the 7 is not common to all of them, I can't pull out a GCF. But I should be thinking about GCFs when I'm doing some of these problems. We just haven't run into one yet that has that. So to get started, let's go ahead and go after that AC method. We're going to get some big numbers here, but don't be afraid. So we have A is 14, B is 41, C is negative 28. Okay, so AC method. So at the top I have A times C, which is 14 times a negative 28. And at the bottom I have B, which is 41. So here for the A times C, I have 14 times 28, and you can do that right off to the side of your paper, but you get negative 392. Holy cow. Now I'm not going to really worry about the negative part of the 392. I just want to look for combinations that could work here. So I'm going to look at 1 and 392. Now I could also take 392 and divide it by 2. That give me 196. Let's look to see if it's divisible by 3. 9 plus 3 is 12. 12 plus 2 is 14. So 14 is not divisible by 3, so neither is 392. 4 goes into 392. Let's see. 9 times 4 is 36. Remainder of 3. 8 times 4 is 32. So it goes 98 times. Now notice we're getting close to our answer. The difference between 1 and 392 is 391 units. The difference between 2 and 196 units is 194 units. So you can see I have gone from 391 to 194, and now I'm at 94 is my difference here. So again, I'm trying to sneak in on that till I can get somewhere that's kind of close to 41. Now 6 is not going to work because 2 and 3 are not in my list. 7 could work. If we check 7 real quick, 7 goes into 39. Let's say 7 times 5 is 35, remainder of 4. 7 goes into 42 6 times. Oh, that looks good. 7 and 56. If we look at 7 and 56, you can tell that we're getting very, very close here. Okay, since 392 is even, let's go ahead and look at 8 as well. Now if I take 392 and divide that by 8, let's see, 8 times 4 is 32, remainder of 7. 8 goes into 72 9 times. So here it is, 8 and 49. That's perfectly, this is what I want. So I need these to multiply together to give me a negative 392. So one will have to be positive and one will have to be negative. But when I multiply them together, or sorry, when I add them together, I want a positive 41. So I have a positive 41 and a negative 8. So this is my combination that works. So let's take our 14x squared. And now instead of 41x, let's rewrite it as 49x minus 8x minus 28. Grouping, we're going to take these two groups together. We're going to go ahead and pull out a 7x. If I factor out a 7x, I'm left with 2x plus 7. And 28, 7 times 4 is 28. 8 doesn't go into 28, so I think the most I can pull out here is probably a 4. We'll check that. So let's go ahead and pull out, not just a 4, let's pull out a minus 4. And then I'm left with 2x plus 7. And then I have this nice little GCF, 2x plus 7. And then I'm left with 7x minus 4. And you can check this by foiling it out, or we can use my preferred method and use the box method, and then that kind of is a self-check. Minus 8x minus 28. So let's factor here. First column, I have a 2x. Second column, it looks like I have a positive 7 as my GCF. First row, it looks like I have a 2x, that's my greatest common factor. And in my last row, I think we have a minus, let me see here, 2. Wait, instead of the 2 here, 2 doesn't go into 49. That's not possible. I think we need to choose higher there. So on our first row, let's choose a 7x. And then on my last row, let's choose a minus 4. 7x times 2x is 14x squared. 7x times 7 is 49x. Negative 4 times 2x is a negative 8x, and negative 4 times 7 is a negative 28. So this checks even before we factor it. So I'm left with 2x plus 7 and 7x minus 4. So that box method is nice because it checks itself when you run through your factors. Okay, let's go ahead and factor another trinomial. Seems to be the entire assignment, factoring trinomials. So for this next one, let's look at the trinomial 20y squared plus 68y minus 48. And again, our job here is to factor. Well, the thing I noticed first about this particular trinomial is all the coefficients, 20, 68, and 48, are all even numbers. So that tells me that they have a common factor of 2. And I should always pull out a greatest common factor if I can. So it looks like 2 is common. And then I also look at 4, because 4 goes into 20, 4 goes into 48, and 4 goes into 68 as well. So I want to pull out 4 as my greatest common factor before I even get started. So if I factor out a 4, I'm left with 5y squared plus, now 4 goes into 68 17 times, 4 goes into 48 12 times. 12 times 4 is 48. So when I factor this, really the only thing I need to do now is to focus in on this 5y squared plus 17y minus 12, but then I have to remember this 4 out front. So when I get all done, I should have a 4 times stuff. Okay, but don't forget the 4. So as we continue on here, I get a is 5, b is 17, and c is negative 12. So let's go ahead and use the AC method on this. Now remember, I'm keeping track of that 4. Don't forget the 4. So for the AC method, I need two numbers, AC multiplied together, that give me negative 60, because 5 times negative 12, added together gives me 17. So let's just go ahead and start with our list. 1 is 60. Those don't get me anywhere, 17, no matter how the signs are positive or negative. 2 and 30. Now notice, here I'm 59 units apart. Now I'm only 28 units apart. 3 and 20. Boy, that one looks promising, doesn't it? Because 3 and 20 are 17 units apart. So let's see if I can make my signs work here. So if I make this a plus 20 and a minus 3, negative 3 times 20 is negative 60. Negative 3 plus 20 is 17. So that's what I want to do, is I want to take this 5y squared plus 17y minus 12, and I want to rewrite that. So I have 5y squared. Now instead of plus 17y, I want to put plus 20y minus 3y minus 12. Now these two combine right here to 17y. So, factoring by grouping, I'd go ahead and factor out a 5y. If I factor out a 5y, I'm left with y plus 4. Now over here, I could factor out a plus 3, but I see that both of these are negative. So let's go ahead and pull out a negative 3. And when I factor out a negative 3, I'll be left with y plus 4. Then I can see my GCF is y plus 4. And my other factor then would be 5y minus 3. Now this is where we could possibly make a mistake. Don't forget the 4. And again, the 4 comes into play because of our greatest common factor out front. Okay, using my little box method, I would put down 5y squared plus 20y minus 3y minus 12. Okay, and then I'd go ahead and factor. Greatest common factor in the first column looks like it's a y. Greatest common factor in the second column looks like it's a 4, say a plus 4. Greatest common factor in my first row is 5y. Greatest common factor in my second row is a negative 3. So here I have y plus 4, 5y minus 3. Let's check our work. 5y times y is 5y squared. 5y times 4 is 20y. Negative 3 times y is negative 3y. Negative 3 times 4 is negative 12. So these are my factors, and I've already double checked my work, so I don't have to foil it to see if what I'm doing is correct. I just need to make sure that I include the 4, because without that 4 out front, it will be counted incorrect. So in this case, we needed to find that greatest common factor before we were able to use the AC method. Okay, let's go ahead and look at another problem. 15x squared minus 25x minus 10. And again, our rule here is to factor. But just like we had up here, a greatest common factor first, I think down here we do as well. So here between the 15, the 25, and the 10, I do have a greatest common factor of 5. If I factor out that greatest common factor of 5, I'm left with 3x squared minus 5x minus 2. Okay, so then, using the AC method, we should be able to factor. But again, what we need to remember is at the end, I must include this 5. So for the AC method, A is 3, B is negative 5, and C is negative 2. So here's my AC. 3 times negative 2 is negative 6. B is negative 5. This one shouldn't be bad. I can have 1 and 6 and 2 and 3. 1 times 6 is 6. 2 times 3 is 6. Now I need two numbers multiplied together that give me a negative 6. Well, in order for me to get negative 6, either the 1 or the 6 would have to be negative, or the 2, 3. I need to find the combination that yields a negative 5 when I combine them. Now the 2, 3 looks like it has potential. If these were both negative, when I combine them I'd get a negative 5. But if they were both negative, when I multiply them I'd get a positive 6, so that won't work. So it looks like it's close, but it won't quite work. So this is my combination I want, is the 1 and the negative 6. Our next step is to rewrite. Remember that 5 is out front. So I have that 3x squared. Now instead of a minus 5x, I'll put a minus 6x plus 1x, or just x. And here we are. Oh, and minus 2. Greatest common factor in my first group is 3x. If I factor out a 3x, I'm left with x minus 2. Now if you notice, I already have just an entire x minus 2 here. So what I might want to think about is writing that as a plus 1 times the quantity x minus 2. So that way when I factor this out, I'll be left with 3x plus 1. Because again, a lot of people have that problem when they factor out this x minus 2 that they're left with 0 over here, but that's not correct. And then of course we need the 5 from my greatest common factor in the beginning of the problem. We need to make sure we include that. Okay, my little box method, we'd have 3x squared minus 6x plus x minus 2. So greatest common factor in the first column is an x. Greatest common factor in the second column is a minus 2. Greatest common factor in the first row is a 3x. And if you notice, there is no GCF in the last row, it's just a 1. So my solution here, 3x times x is 3x squared. 3x times negative 2 is a negative 6x. 1 times x is x. 1 times negative 2 is negative 2. So I've already checked my work. And I'm left with 3x plus 1 times x minus 2. And again, I need to pull that 5 down from the original greatest common factor. So when you're working with greatest common factors, it is important to make sure that you pull all of those out. Okay, let's check our time for one more problem here. Okay. Let's look at 12u cubed plus 20u squared minus 48u. Now this one has a u in each term, and I think I can pull a 2, oh wait, probably a 4 out of each one. So here my 4u is my greatest common factor. So if I pull a 4u or factor a 4u out, I'm left with 3u squared plus 5u minus 12. 12 times 4 is 48. So again, I need to remember a 4u out front. So let's go ahead and use the AC method, and with the AC method, A is 3, B is 5, and C is negative 12. So for the AC method, I start with AC up top. I need two numbers multiplied together that give me a negative 36, added together that give me a 5. Okay, so 1 and 36 aren't going to do the job. 2 and 18, not close enough. 1, 2, 3 and 12, that's not going to work. 4 and 9, that has some potential. 4 and 9 are a difference of 5 apart. If I make the 9 positive and the 4 negative, negative 4 plus 9 is 5. Negative 4 times 9 is negative 36. So these are the numbers that I'm looking for. Our next step would be to rewrite 3u squared minus 4u plus 9u minus 12. And again, this is just taking the 5u and rewriting it. Greatest common factor in my first group for this particular problem looks to be a u. If I factor out the u, I'm left with 3u minus 4. Greatest common factor is a 3. If I factor out the 3, I'm left also with 3u minus 4. Greatest common factor between the two groups is 3u minus 4, and I'm left with u plus 3. And then of course I need to remember from up top that 4u from before, my greatest common factor. Okay, I like to look at this in terms of the box method. Okay, so for my box method, greatest common factor in my first column is 3u. Greatest common factor in my second column is minus 4. Greatest common factor in my first row is u. Greatest common factor in my second row is 3. u times 3u is 3u squared. u times negative 4 is a negative 4u. 3 times 3u is 9u, and 3 times negative 4 is negative 12. So that's my factored form. This is a positive 3. So I have 3u minus 4 times u plus 3. And again, I need to make sure I have this 4u out front. So you can see either method, whether you use the AC method with factoring by grouping or the AC method with the box method for factoring, either way works good. These are tough problems, and when you go through this part over here with the AC method, when you're looking for that combination of numbers, you just really need to write them all out. You can't give up. You can't just say, oh, I can't find the correct values that work. You need to write out all the factors and then consider which ones could combine to make this constant value of b down here. So if the problems get tough, don't give up. I know you guys can do this. Good luck on your homework, and please let me know if you have any questions.